Good morning to all of you. Now you know what is today's task. Today's task is to find or to prove the theorem of parallel axes. Of course you have done it in 11th and 12th. You know that if you want to find the moment of inertia about an axis which is parallel to x-axis, then it is the sum of two quantities. One is ma square plus the moment of inertia about the center of mass or about the center of gravity. But here we are dealing with rigid bodies, and the rigid bodies are in 3 dimensions. So we have to consider the result of 3 dimensions. We have to evaluate it in that way and use it for our problems. Okay. So the statement of this theorem is, given moments and products of inertia about all axes. Which are these axes? X, Y, Z. We have 3 mutually perpendicular axes through CG. So if the moments of inertia and products of inertia of a body is calculated along 3 axes passing through the center of gravity, that is known. That means the moment of inertia of this body about gx dash, about gy dash, about gz dash is known to us. We already obtained that. Is that clear? Then we can find its moment of inertia about the axes, parallel axes, about the axis OX, about the axis OY, and about the axis OZ. So first of all we will be doing for the Z axis, and rest of the axis you can do by yourself with the help of this result. Okay. So let us start. Given moments and products of inertia about all axes through CG of a body, we can find these moments and products of inertia about all parallel axes. So for that we have to consider the rigid body like this and consider elementary mass. Whenever we want to find the moment of inertia, we consider a elementary mass. So let us assume that the elementary mass is present at P, that is small m. So m with the mass present at P. Now this point P has coordinates small xyz, not small xyz, they of course small xyz. You know coordinates we write by small letters, whereas axes we write by capital letters. So this x, y, z, these are the coordinates with respect to x-axis, y-axis and z-axis. It is in 3 dimensions, but you can say roughly that this length will be your x. Of course, x will be the length which you will, that is the length of the perpendicular. Perpendicular is dropped from P on the plane XOY. So that length will be x. Okay. So P has coordinates x, y, z with respect to OX, OY, OZ. Now let us draw 3 more axes. These are passing through the center of gravity of the body. These axes are gx dash, gy dash and gz dash. And let us assume that x bar, y bar, z bar, these are the coordinates of G with respect to OX, OY and OZ. What else? Let us assume that the coordinate for P are x dash, y dash, z dash with respect to gx dash, gy dash, gz dash. Okay. So, what is our target? Our target is to find the moment of inertia about these three axes, and I am taking the z axis. Okay. So, moment of inertia of this body, this rigid body about the axis OZ will be summation of mass into its perpendicular distance is square. So, it is summation of m y square plus z square, because you know the distance will be under root of y square plus z square from the z axis. So, square of that will be y square plus z square. Okay. Now, you can see that this whole length is x, whereas x bar is the x coordinate of g. That means this length is x bar and this length is x dash. Of course, you have to imagine the plane like this. It is a three-dimensional figure. But if you wish to observe, if you want to get the point, then you can observe that this whole length is x, this is x bar, this is x dash, means x is nothing but the sum of these two quantities, x bar plus x dash. Okay. So, x is x bar plus x dash, y is y bar plus y dash, and similarly z is z bar plus z dash. Now, let us move to our target. We want to find the moment of inertia about z axis. So, it is coming as summation m y square plus z square. Put the value of y, put the value of x from these two. So, in place of y, you will put y bar plus y dash and its whole square. In place of z, you will put z bar plus z dash and then its whole square. Open the bracket. You will get how many terms? 6 terms. 2 squared. So, you will get 6 terms. So, out of those 6 terms, 2 terms will vanish and rest of the terms, they will be equivalent to capital M x bar square plus y bar square plus summation of m y dash square plus x dash square, and the remaining terms will be vanishing. Why they are vanishing? Because summation mx dash and summation my dash, they will be 0. So, product term will vanish since center of gravity is the origin of gx dash, gy dash, gz dash. You know, the CG of this body about this very point will be 0, 0, 0. So, you know the formula for CG. What is the formula for CG? It is summation mx dash divided by summation m. So, it will become 0. So, that is why the rest of the 2 terms will be 0. So, we found the result. The result is moment of inertia about z axis is the sum of 2 quantities, and these 2 quantities are this and this. Now, let us elaborate. Let us give wordings to it. That is, moment of inertia about z axis is moment of inertia of the body whose mass is whole mass is acting at suppose that the whole mass is collected and it is acting at G plus one more term, that term is plus mass into perpendicular distance square. Mass into perpendicular distance square. Why? Because this is the perpendicular distance square with respect to gx dash, gy dash, gz dash. So mass into perpendicular distance square from gx dash, gy dash and gz dash. What does it mean? It means that the moment of inertia is smallest when you obtain it with respect to the center of gravity. So, if you want to find the moment of inertia about a parallel axis, this is the parallel axis, then it will be the sum of two quantities, moment of inertia about G plus the mass is collected, total mass is collected at the center and then perpendicular distance square. So this the sum of two quantities and there you have only one quantity. So that is the least moment of inertia, and that is why you know that it is quite easy to rotate a body about its center of inertia instead of about an axis which is parallel to center of inertia. So this result is valid for x-axis, y-axis and z-axis, or this result is valid for any arbitrary line which is parallel to a line passing through the center of gravity. Okay? Is that clear? Now, the thing which we have obtained for the moment of inertia, the same thing we can obtain for the product of inertia. Now, product of inertia, if you can recall, moment of inertia about z-axis, it is termed as about x-axis, moment of inertia about OX, it is written as capital A. About OY, it is written as capital B. About OZ, it is written as capital C. Now after that, I have introduced three more terms. They are for the product of inertia. Product of inertia about x-axis means it is summation yz. So it will be given by D about y-axis, it is given by E, and about z-axis, it is given by F. So So if it is a case of 2 dimension, then only this and this will come. But if it is a case of 3 dimension, then all these 6 quantities will come. Now, let us find out the product of inertia about z-axis. OZ. What it will be? It will be summation of M x y. What you have to do? Again you have to put the values of x and y in terms of bar and dash. So you will get the result as summation M x is x bar plus x dash, y is y bar plus y dash. Okay, so when you open this, it will be summation M x bar y bar plus summation M x bar y dash plus summation M x dash y bar plus summation M x dash y dash. Okay. So these are the 4 terms you will be getting. Now there is an important point that if you have this result x bar y bar, you know, whatever particle you choose from this arbitrary body, you can choose this particle, 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 but x bar, y bar, z bar is fixed. So that does not vary with the choice of the particle. Is this point clear? So it can be taken outside the summation. So here you can take x bar, y bar, and then summation M. What is summation M? That is the total mass of the body. Okay. Similarly, here you will get x bar outside, but you will get summation my dash. Here you will get y bar outside and you will get summation mx dash, and here you will get plus summation m x dash y dash. Now you know that this term and this term, they will be 0. Why they will be 0? I told you the reason, that the x dash, y dash, z dash, these are the coordinates of the particle with respect to gx dash, gy dash, gz dash. So this center must be treated as 0, 0, 0. So summation mx dash will be 0. Summation my dash will be 0, but still this will not be 0. That's a very important point, because this is the product term, so you can't take anything outside. So you have obtained the same result, that is, the product of inertia about z-axis will be the sum of 2 quantities. One is, suppose the total mass is collected at G, center of gravity, and its moment of inertia plus the moment of inertia of the body with respect to gx dash, gy dash, gz dash. So again, you can see that it is a sum of summation mxy is a sum of these two quantities. So it will be least when you consider only this term. This is omitted if you consider the axis gx dash, gy dash, gz dash itself. Okay, so this is termed as f. Now we have found the result for C and F. Similar results you can find for A, B and D, E. So that follows directly. So you can just state that similarly we can find the moment of inertia of the rigid body about the three parallel axes OX, OY and OZ, and we can find the product of inertia about the axes OX, OY and OZ by knowing the moments and products of inertia about gx dash, gy dash and gz dash. So that's all for the theorem of parallel axes. Now it has two corollaries. So next time we will work out the corollary. Thank you very much.